Hello and welcome to another one of these ADD videos. Today we're going to be looking at trigonometric functions. Whenever you drop a line to the x-axis, oh, sorry, I did it again, didn't I? I keep forgetting that I put layers on here. Let's go back to the canvas. So whenever you drop layers on the x-axis, you get a right triangle. Okay, making sure that it's a perpendicular line, and as a result you can get 6 trig functions. There's sine, which is the opposite leg over the hypotenuse. I guess I didn't go over the 3 definitions. The hypotenuse is this main leg here, and then we have O as the opposite leg, and I guess it's not letting me highlight that. Okay, and A is the adjacent leg. So based off of that, a few things emerge. First, there's trigonometric functions that emerge. We know that sine is the opposite leg over the hypotenuse, and its reciprocal, cosecant, is hypotenuse over opposite as a result. If we look at cosine, we have adjacent over hypotenuse, and its reciprocal, secant, is hypotenuse over adjacent. And then if we look at tangent, we're going to have opposite over adjacent, and cotangent as a result, the reciprocal is going to be adjacent over opposite. Okay, make sure you know those. You got to know those. They're going to come up time and time again. And there are many ways to deal with problems like this. So this is just a foundational basis for the 6 trig functions. Another thing that helps you memorize these things are acronyms. So the acronym here is SOHCAHTOA. Some people have come to me with more creative, hippie stories and other things and whatever. SOHCAHTOA works best for me. Sine is the opposite over hypotenuse, the O, and then cosine is adjacent over hypotenuse, the A, and tangent is the OA, the opposite over hypotenuse. Whatever you got to do to memorize it, flashcards, whatever makes you happy. Okay. There's also a relationship between the legs of that right triangle called the Pythagorean theorem. And the Pythagorean theorem basically says that if you take the legs and you square them and you add them together, you get the hypotenuse. So as a result, the opposite leg equals the hypotenuse squared. So as a result, the hypotenuse will always be positive because we're adding 2 positive numbers. Because when you square a number and add it to another square number, squared numbers are always positive, so hypotenuse has to always be positive. Okay, so back to our trig functions. Now there's an acronym that helps you memorize what functions are positive in the different quadrants. Okay, if you remember, the quadrants are 1, I guess I'm on a layer now, layer 2 maybe. This is quadrant 1, quadrant 2, I guess my marker's too fat. So this is quadrant 1, 2, 3, just refreshing your memory, 4. Okay, and based off of that, there's an acronym that says all students take calculus. So all students take calculus. And the way that helps us is we know, based off the first letter, which ones are positive where. Let me show you what I mean by that. So we have all of them is pretty self-explanatory. In the first quadrant, they're all positive, so no acronym needed. But students starts with an S. And in quadrant 2, students goes, and that means sine, and it's reciprocal cosecant. A lot of people want to mess with cosecant and secant because they sound alike, and cosine and sine. I don't know why whoever came up with these names didn't think about that, but hey, hindsight's 20/20, right? So take in the third quadrant is tangent and cotangent, and calculus starts with a C, so that's in the fourth quadrant. Highlight there. The fourth quadrant, and that's cosine, and it's inverse secant. Okay, all students take calculus. Tells you what trig function is positive in what quadrant. Okay. Then we should talk about a reference angle. A reference angle is an angle made by the terminal leg and the x-axis. I can't tell you how many times people try to connect it to the y-axis. Don't do it. It won't get you the right answer ever. So if we're dealing with degrees, in the first quadrant, it's always theta as a reference angle, and then you do 180 minus theta in the second, 180 plus theta in the third, and 360 minus theta in the fourth. Okay, so if I'm looking for a reference angle, for instance, and I know, I think I have these two backwards, don't I? I've been working since 5 a.m. I'm sorry. It's 4 hours in, or 3 hours in. So let's say I have 210, for instance. Let's just work it out. So if my angle is 210, that puts me in the third quadrant. And to get the reference angle, if I did plus 180, that wouldn't work. It'd have to be minus. So if I did minus 180, I get the reference angle of 30 degrees. So I need to change this. I'm sorry, people. This should have been theta minus 180. This is what happens when you rush when you're making stuff up. Okay, and if I'm looking in the third quadrant, it's 360 minus theta. Everything else is okay. So you got a free example out of your concept video. All right, so back to reference angles. So always with the x-axis. Why are we erasing instead of highlighting people? So this is technical difficulties. Sorry, people. There we go. And then back to highlighter mode. There we go. All right. So there are certain angles that show up in each quadrant frequently when we're dealing with trig, 30, 45, and 60. And whenever we do that, if you want to save some time, what you can do is you can remember that whenever we have these reference angles, the denominators are fixed no matter what quadrant we're in. If it's 30, the denominator will always be 6. If the reference angle is 45, the denominator is always 4. And if it's 60, the denominator is always 3. So with that in mind, I've come up with a little relationship between numerator and denominator, which I haven't seen in a textbook yet. Then again, my graphing technique wasn't in a textbook and then showed up a few years after I put my handout online, so maybe this will show up somewhere soon enough. But basically, the relationship exists between the numerator and denominator. In the first quadrant, we are always going to have pi over whatever, 3, 4, or 6. But in the second quadrant, if you have one of those reference angles, only with those 3 reference angles, you would have a numerator that's 1 less than whatever that denominator is. In the third quadrant, it's always 1 more. And in the fourth quadrant, twice the denominator minus 1. How can this help me? Well, let's say I needed 45 degrees in the second quadrant. Well, I know that 45 degrees has a denominator of, how many of you were paying attention or took notes? Let's look back down. 45 degrees is a 4. So in the second quadrant, I know that it's 1 less than the denominator, so I know right away that that angle would be 3 pi over 4. Whereas if it was in the fourth quadrant in radian measure, and I have a 45 degree reference angle, that would be twice the denominator, so 8 minus 1 is 7 pi over 4. And I'll show you later on how this trick will be beneficial to you, okay? But each of these things have, if you remember, sine and cosine functions oscillate between 1 and negative 1. So if we look at the unit circle, we can come up with the different angles, the main angles on the axes pretty easily, okay? So the way you do it is you just plot a point on the unit circle going 1 in each direction, and the first one is going to be cosine and the second one's going to be sine. So for instance, if I wanted the cosine of pi over 2, I know if I go up 1, that point is 0, 1, and the first point is cosine, so the cosine of pi over 2, sorry about that, would be 0. Or if I wanted the sine or the cosine of pi, well, I come over here. If I go to the left 1 unit, that point is negative 1, 0. The first point is, the x value is your cosine, okay? But the other angles are a little bit more intricate, the reference angles that we deal with a lot. So the way I do it is I come up with this table. And the way this table works is pretty straightforward. If you can count to 4, starting from 0, and then work your way back down. And divide everybody by 2 and square root everything. You've just found 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, the sine and the cosine. If we're doing in radian measure, that would be pi over 6, pi over 4, pi over 3. Notice that the denominators are what I told you they were earlier. So how would this table work? Well, let's say I want, I didn't do tangent, sorry. And then tangent, you just divide the numerators, and you don't worry about the 2. So 0 over the square root of 4, or 0 over 2, is 0. Then 1 over root 3, is the square root of 1 is 1. Root 2 over root 2 divided by root 2 over root 2 is 1. And we have root 3 over 1 and undefined. So how am I doing this? Well, okay, let's say I wanted the sine of the reference angle of 30. Well, I would come to this point here and see where they intersect. Sine and 30 intersect here. So that's a 1 in the numerator, square root that value, you get 1, and then divide it by 2. So sine of 30, for instance, is 1 over 2. Let's look at a different angle. Let's look at the cosine of that same angle, 30. So if I'm doing the cosine of 30, let's use a different color so you can actually see it. Cosine of 30, you come over here to 30 degrees, come down to cosine, that's a 3. So it would be the square root of 3 divided by 2. Okay, and tangent is pretty self-explanatory. So depending on what quadrant you were, you would use this acronym that all students take calculus to determine if it's positive or negative. Okay, so if we're in the third quadrant, that cosine would have been negative. Okay, and this angle would have been 210 or 7 pi over 6. Now all that just probably flew over your head if this is your first time looking at trig. Watch this video again if you need to. Pause it a little bit, take some notes, understand what's going on, and then watch the example videos. Okay, and the example videos usually clarify things pretty much to a point where you shouldn't have any questions and you can practice your problems. Okay, so this is a lot of information. Make sure you get a solid foundation, because like I said, there are a couple chapters dedicated to this and it only gets harder, so make sure your foundation is solid. Thank you and have a nice day.